For the Krebs cycle, oxidative decarboxylation occurs in which the two pyruvic acid molecules produced from one glucose molecule is converted into 2-NADH acetyl coenzyme A, CO2 and hydrogen ions with the help of pyruvate dehydrogenase and magnesium ions, and the enzymes involved are coenzyme A and NAD. And after the process of oxidative decarboxylation, tricarboxylic acid cycle or the Krebs cycle occurs. Now the TCA cycle starts with the condensation of acetyl group with oxaloacetic acid and water to yield citric acid. So this reaction is catalyzed by enzyme citrase synthase and a molecule of CO is released. Now, the oxidative decarboxylation reaction, which we have previously spoken about, is nothing but a link reaction of the transition reaction or a gateway reaction that occurs in matrix of mitochondria. The next step, which is involved in aerobic respiration, is the TCA or citric acid cycle. So, in the citric acid cycle, you can see here that the pyruvic acid, that is two molecules of pyruvic acid, are converted to two molecules of acetyl coenzyme A with the help of NAD and magnesium ions. Biotin enzyme is also involved, and then two molecules of acetyl coenzyme A is formed. Now this 2-acetyl coenzyme A, which is formed as an acetylation of pyruvic acid, will react with the oxaloacetic acid, which is a 4-carbon compound, and acetyl coenzyme A is a 2-carbon compound. When both react, they form citric acid. Therefore, the name citric acid cycle. Now, they form citric acid with the help of citrase synthase. Now, as we have said earlier, that there is removal of carbon dioxide, and every time a carbon is removed, NAD is converted into NADH2. So, this citric acid is then converted into isocitrate, that is, it isomerizes, which is a 6-carbon carbon compound. And now there is a removal of carbon dioxide molecule, and therefore there is a conversion of NAD to NADH2, and it forms alpha ketoglutarate, which is a 5-carbon compound. Therefore, a carbon dioxide is released here, and then the coenzyme A is released in the next step. Now, the alpha ketoglutarate is then converted into succinyl coenzyme A. Therefore, there is a conversion of NAD to NADH2 and removal of carbon dioxide molecule. Now, succinyl coenzyme A is a 4-carbon compound. Now, this succinyl coenzyme A compound is then forms succinic acid. Here, when there is conversion of succinyl coenzyme A to succinic acid, there is conversion of GDP to GTP, which then forms ATP. Now, it is a substrate level phosphorylation process. Now, from succinic acid, it forms fumarate. Therefore, there is conversion of 1-FAD to FADH2, and the enzymes involved are succinate dehydrogenase and link enzyme. And then the fumarate forms malate with the help of the enzyme fumarase, and the malate forms two oxaloacid molecules, therefore re-entering the cycle. And here the enzyme involved is malate dehydrogenase. Now, here again there is removal of a carbon molecule and therefore conversion of NAD to NADH2. And all the electrons involved in the removal of these hydrogen atoms, they then enter the electron transport chain.